Hi everyone, this is example 6 from module 10 on page 192, and we're going to look at how to do two different types of tests on the TI calculator. So for example 6, we're going to use the one sample t-test, and t-tests use data from samples. Heights of people the same gender and similar in age are approximately normal. You know from government data that the mean height of young men is 69.5 inches, and standard deviation of the heights of young men is about 2.8 inches. Suppose the mean height of all male students at LMC is 70 inches. So if you choose 250 male students from LMC to measure heights, what is the population that you're using to compare them to, and what is the sample? So the population is all young men, or the heights of all young men. The sample is the heights of 250 male LMC students. Okay. So our sample again is the heights of all young men that we can get from this government data, and the sample is the heights of the 250 male LMC students. Part B tells us you are fairly sure that the mean height of male LMC students is greater than the mean height of all young men. Carry out a hypothesis test for this claim. So we want to first define our mu sub 0, our x bar, and our null and alternative hypothesis. So for mu sub 0, we're going to use the population value, the 69.5 inches, height that goes with all young men. For x bar, and I don't have a way to put the bar on top, so you'll have to know which x I mean. That's from our LMC sample, and that height was 70 inches. Okay, our null hypothesis is going to be that the mean equals 69.5. And our alternative hypothesis, we're saying that LMC students are taller, so that's going to be that the mean is greater than 69.5 inches. So now we want to calculate the sample standard deviation for these male students. So we're going to use here our sample standard deviation formula. And your calculator puts an x next to the s just so that you know that it's coming from the sample. And so we're going to take our population standard deviation 2.8 and divide it by the square root of 250, because 250 is our sample size. And we end up with 0.177 inches is the sample standard deviation. Remember, when we take a large sample, the standard deviation gets compressed. Now, in step 3, we're going to go ahead and use our graphing calculator to find the t-score and the corresponding p-value. So you could crank it out with all the formulas that we saw earlier in the packet. So be my guest to use the formulas. I'm going to use the graphing calculator. So I'm going to go to stat, and then I'm going to arrow right to tests. And then I'm going to run choice 2, the t-test. And the reason we use the t-test is our data comes from sample. So this is because we are using sample data. And we're going to get a t-score, which is analogous to the z-score. But because it comes from a sample, they call it the t-score. So we get a really high t-score here when you type this on your calculator. We get t equals 44.64. So I'm going to put a note, this is very high. That's a lot of standard deviations. And then we get a p-score that is so small, it gets rounded to 0. Okay, so what can we conclude now? We got a really small p-value, much less than 5%, right? So the p-value is really small, less than 5%, or our 0.05 that we usually compare to. So we can conclude there is enough evidence to reject the null hypothesis. The sample does support the claim that the mean height of male LMC students is greater than all young men. So this is small p-value, so we can go ahead and reject the null hypothesis and go with this alternative hypothesis. So to recap, this was the one sample t-test, and our one sample here was these male LMC students. Now on page 193, we're going to look at another example using the two-sample t-test on our TI calculator. So in a recent study, medical doctor James Levine and his collaborators at the Mayo Clinic investigated the link between obesity and energy spent on daily activity to see if non-obese subjects are more active. For the study, the doctors chose healthy volunteers who identified themselves as not exercising regularly, collected data, and then sorted by obese or not obese. A random sample was chosen and minutes per day of activity were measured. So we've got these two groups, the non-obese group and the obese group. They had different sample sizes. That's okay, we can still compare. They had different means and different standard deviations. So we're looking at two different groups. So this is two samples. So we're going to use this two-sample t-test. So let's go ahead and state our hypotheses. So we first want to define our mu sub 0. So mu sub 0 is going to be the average minutes per day having difference 0, we could say. Or we could say in parentheses, no change. That sounds a little more normal. Then x1, and pretend my x's have bars, is going to be 525.751 minutes for the not obese group. So I'm just taking the first row is x1. It doesn't really matter what you choose as long as you're consistent. And x2 will be 373.269 minutes for the obese group. And so then we want to say h sub 0, our null hypothesis, is going to be that mean 1 equals mean 2, that there is no difference. Our alternative hypothesis is going to be that mean 1 is greater than mean 2. So now we can calculate the difference in the sample values. So x1 minus x2, and pretend these numbers have bars over them, is going to be 525.751 subtract 373.269, and that difference is 152.482. Okay, so we see there is some difference. So we need to investigate if this difference is statistically significant. Okay, so step 3 asks us to use our graphing calculator or formulas to find the t-score and the corresponding p-value. So on your calculator, you're going to go stat, and then you're going to go into tests, and then you're going to choose choice 4, the 2-sample t-test. And then enter the data that you see there for pooled. When you get to that question, choose no. We don't want to pool our data. And we get a p-value equals 0.0013 after some rounding. And the t-value equals 3.71. Remember, this t-value is basically telling us how many standard deviations or sample standard deviations away it is. So that standard deviation is high. Our p-value is very small. So since our p-value is very small, we can conclude that there's enough evidence to reject the null hypothesis. So we can say the sample does support the claim that non-obese subjects are more active. Okay, so now we've seen the 2 types of t-tests you can run on your calculator. Go ahead and practice these in the group assignment and lab assignment.